Good morning, students. I hope you all are doing great and staying inside. From today onward, we are starting online classes. In this session, we will talk about number system which we use in everyday life. That is, in measuring distance, size, time, weight, temperature, we all need numbers. In maths, these numbers represented in number line, which we normally call number line. As you can see, I have already drawn a number line, which includes 0, -1, -2, -3, -4. These all are negative numbers in the left hand side and all positive numbers in right hand side, which include 1, 2, 3, 4. As you all know, from your previous knowledge, all the negative numbers are called integers. Yes? And all the positive numbers on the right hand side are called natural number. 0, which is neither positive or negative. It doesn't include neither in positive numbers or in negative numbers. So what is 0 then? 0 is basically when included with natural number, these group of numbers are called whole number. As you can see, now I have drawn some diagrammatic system which include firstly integer. We all know now that negative integers and the whole numbers are included in integers. And whole numbers which include 0 and positive number, which is basically called natural numbers, are called whole numbers. Now these positive numbers are further divided into two, that is prime numbers and composite number. What is prime numbers? Prime numbers has basically exactly 2 divisors and composite numbers have minimum 3 divisors. For example, 2, which have exactly 2 divisors, that is 1 and 2. This is a prime number. And whereas 4, which has 3 divisors, that is 1, 2 and itself 4, which is a composite number. There are many more numbers represented in the form of fraction and decimal. For example, between 0 and 1, 1 by 2 comes, we all know. And 1 by 2 is a fraction. And if we say it in a decimal form, it will be represented as 0.5. Another example is 3 by 2, which is in the... So now we will talk about rational numbers. What are rational numbers? Numbers that can be represented in the form of integer divided integer. That is, we are taking P and Q here, where P and Q are integers. For example, 2 by 3, 5 by 7, 7 by 1. Where 7, 1, -5, 7, 2 and 3 all are integers. 8 by 1, where 8 and 1 both are integers, which can be equal to 8. Similarly, -2 by 1, which can be written as -2. Similarly, -4 by 1, which can be written as -4. So what we mean by that? That means that all the integers are included in our rational number. So what we get to know is that real number include not only integers but also non-integer number. That is, we all know about the fraction. This is a fraction, which is called non-integer numbers. This is also a fraction, which is also a non-integer number. So basically, what is rational number? That is, it includes an integer number and this outside all are non-integer number. Got it? Now we talk about terminating and non-terminating numbers. What are terminating and non-terminating numbers? We will study with an example. Suppose 3 by 2. We have taken a fraction which is a 3 by 2. It is a rational number, we all know, which in decimal form represented as 1.5. That means 3 by 2 is terminate at 5. That is, you got the remainder 0. Where the remainder is 0 and it terminate at certain number, it is called terminating numbers. And if we take another example, 1 by 3, which is in decimal form comes 0.3333 and so on. It doesn't terminate at any certain number. These numbers are called non-terminating numbers. But there are also some number which cannot be written as ratio of two numbers. That is, if we take example root 2. We all have studied a root 2, which is an irrational number, which comes between 1 and 2. It cannot be written as a ratio of two numbers. Why? Because it is a non-terminating and non-repeating number, which does not terminate at a certain number and it does not even repeat, like we have studied 0.33333 repeating at 3. For example, we have taken root 2. It can be written as 1.41421356237 and so on. It does not repeat and neither terminate. Another is pi, which is a pi. It is written as 3.14159265535 and so on. It is also neither repeat and neither terminate. As we all get to know what is rational and irrational number, we come to a new concept called real numbers. That is, real numbers are those numbers which include rational number and irrational numbers. Now we talk about mathematical notations which we are going to use in our further exercises. Basically, what is mathematical notations is a system of symbolic representation of mathematical objects and ideas. For example, natural number, which is basically denoted as n, capital N, which include 1, 2, 3 and so on numbers. Another is whole number, which is denoted as capital W, and this one line is broad and it includes 0, 1, 2, 3 and so on. Integers with capital Z, and this line is bold, which include -1, it includes -3, -2, -1, 0 and all positive numbers, so on. Another is rational numbers, which is denoted as Q. Include all the fractions in the form of P by Q, where P and Q are integers and irrational number are denoted as capital Q complement, which is actually R minus Q. What is R? R is represented as real numbers. As now I am done with the introduction of the chapters and you all have got a quick recap of the chapter, now we will start with further exercises of the chapter. So let's start with a question. Find 5 rational between 1 and 2. We have to find 5 rational numbers between 1 and 2. Before starting this question, we will start with we will understand it with some concept. Take it as A and 2 as B. To find a rational number between A and B, we will add A and B and divide it by 2. That is A plus B by 2. Now let's proceed. First rational number between 1 and 2 equal to 1 plus 2 divided by 2, which will be 3 by 2. Now 3 by 2 comes in between 1 and 2. So the next number will be coming from 3 by 2 and 2. Rational number will be 3 by 2 plus 1 or either 2. You can do anything. 3 by 2 plus 1 or 2. So it will be, and divided by 2. No? So it will be 5 by 4. Third number will be 3 by 2 plus 2 divided by 2, which will be 7 by 4. Similar way, fourth number. We have already learned one process to solve this type of question. Now we will do another method to solve such questions. We will firstly make their denominator same of 3 and 4. Take a bigger number. This is 3 and this 4. Right now the denominator is 1. We will multiply with the number 7. Both in numerator and denominator it will be 21 by 7 and this will be 28 by 7. Now look, these two numbers include already 6 rational numbers in between, which are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. 1, 2, 3, 4, 5, 6, 7. So these are the 6 rational numbers between 3 and 4. It's quite easy method, but we have to do hit and trial in this also. As now we all know there are infinitely many rational numbers between any two numbers. Now we have to find 5 rational numbers between 3 by 5 and 4 by 5. Again, what we will do, we will make their denominator equal. That is 3 by 5 if you multiply it by 10 and 4 by 5 by 10, it will be 30 by 50 and 40 by 50. So now we can find 5 rational numbers in between these two rational numbers easily. That will be 31 by 50, 32 by 50, 33 by 50, 34 by 50 and 35 by 50. And we can see we can also find 10 numbers also. So the next question is state true and false and give reasons why. Every natural number is a whole number. Tell me, is every natural number is a whole number? Yes, because whole number includes 0 and the positive numbers, which are basically natural numbers. So it is true. Second, every integer is a whole number. What? Every integer is a whole number. False. Why? Because negative numbers are not included in whole numbers. Every rational number is a whole number. False. Why? That's all you know. Because all the fractions, either it's 1 by 2, 3 by 2 or any fraction, are never whole numbers. So true, false, false. Now think of, is every integer is a rational number? With this question, your one exercise has been completed. Now we will proceed to another exercise 1.2. Now be ready with your construction box. We are going to construct some diagrams. But before that, we will take a quick recap of Pythagoras Theorem. What is Pythagoras Theorem? Pythagoras Theorem is basically used in only right triangles. That is, one angle is 90. This longest side is called hypotenuse. This is called base, and this is perpendicular. So what its statement? Square of the longest side is equal to sum of these two sides, that is perpendicular square plus base square. Now we will start with a question. We have to locate root 2 on a number line. To locate this number, we will proceed the construction with further steps. Look, step 1. Take a side OA of 1 unit in length. Draw a number line first. Properly take these distances of 1 unit, 1, 2, 3, 4 from the scale. Now look, we have to draw a side OA of length 1 unit. Look, this is OA of length 1 unit. Name it OA. This line. Now in the second step, you have to draw a line AB of 1 unit. This is OA. So AB will be here only. Now draw a line AB of length 1 unit. This is B, and this is also 1. This is also 1 unit. Now in the step 3, look, we can write root 2 in the form of 1 square plus 1 square. What is 1 square? It's 1 only, 1, and it will add to root. Basically, the hypotenuse is also a root of perpendicular square and base square. This is perpendicular square and this is base square. So, this 1 OA is base and AB is perpendicular. Now we have to draw this hypotenuse. So by Pythagoras, draw a line OB. This OB is hypotenuse. Now this is root 2. Got it? Now take this. We have to draw an arc of length OB. In our fourth step, draw an arc of length OB, and where it meets in the number line, it represents root 2. Now you have to draw an arc of OB length, which is root 2. Draw it. Look, this meet the number line at this point. Name it C. And C represent root 2 on a number line. Now the next question is to locate root 3 on the number line. We again use Pythagoras theorem. We know hypotenuse is always equal to square root of perpendicular square plus base square. Now take root 3 as a Pythagoras theorem. Look how we will get root 3. If we take the square of root 2 and sum of 1 square, we will get root 3, where we can take square root of 2 as a base and 1 as a perpendicular. Our first step will be draw root 2 first. Look, we have to draw root 2 as a base. So firstly, we should have root 2 on the number line, and we know how to make root 2. We have done first question. So firstly, we will make again or construct root 2 on our number line. As I have already taught you how to make root 2 or construct root 2 on a number line. But look, firstly I have drawn a line or OA of 1 unit, then draw a line of another 1 unit AB and join OB such that it represents a length of root 2. Now make an arc from point O of length OB, and this will make the number line at C point, which represent root 2. Now this line is root 2. It will be a base for our root 3. It is a base OB, and we will draw a line BD of length 1 unit. Look how we will do it. So this line OB, this is OA, and it is AB. Now the step 2, we have to draw OB as a base, we have already done, and draw BD of unit 1. This is BD. Now we have to draw BD. Look, this is B and this point will be D. Name it D. Now join OD. Done. And this distance is root 3. Now this is of length 1. Now draw arc from O of length OD, that is root 3. Look this, and make an arc which cut our number line at point this. It should cut our number line, and this is, name this point as E, which represent root 3. Make sure this point should be 90 degree using your protractor. Now, one more time, I'm explaining how to draw root 3. Now, I'm taking the distance of this as 1 unit. From here to here, 1, 2, 3, 4, 5, and 6. Look, this is what I have drawn, taking this as a 1 unit, 0, 1, 2, 3. Now, draw an arc, make a perpendicular distance, and join this OA. Look, this is a line of length 1 unit. Now name it AB. This is OA, and join BO. This is BO, which is of length root 2. Now taking root 2 as a base and 1 as a perpendicular distance, again OB. Now OB is a base. Draw BD as height or perpendicular. From B, make another arc. This 60. This is 90, and again we have to draw height of 1 centimeter. This is of root 2 base. From here to here, it is 1 distance. $90. This is perpendicular. Now join. Name it D. So OD. Join OD. This will be root 3. Now what I have told you, for root 2, you have to draw an arc which will cut our number line of distance root 2 or OB. Draw it. It will cut our number line at C point, which is root 2. Now for root 3, make another arc of distance OD. Do it carefully, and this will cut our number line at point E, and this will represent root 3 on the number line. Now I hope you all understand it very easily. Name it root 3, root 2. This is all we have done. So in this way we can locate any root n for any positive integer n after root n minus 1 has been located. That is, for root 3, we have to locate first root 2. If we have root 2, we can locate root 3. If we have root 5, we can locate root 6. If we have root 7, we can locate root 8. Got it? Now we are going to solve the last question of this exercise. We have to represent root 5 on the number line. Now we all know by Pythagoras theorem that hypotenuse is always under root of b square plus p square, that is base and perpendicular. How we can write root 5? Root 5 is always equal to square of 2 plus square of 1, that is root 5. Now basically the triangle which we are going to draw will be like this, where we are taking 2 as base and 1 as perpendicular. Got it? And this line, the longest side will be root 5. So let's begin. Now we have to draw root 5. I have drawn a number line. Look, 0, 1, 2, 3 with this distance as a 1 unit, 2 unit, 3 unit. Firstly, we have to draw a base. Look, base is of 2 centimeter. So look, this is 0, 1, 2. This is of 2 centimeter. As you can see, name it OA 2 centimeter. Got it? Now we have to draw perpendicular of length 1. For that, you can use a protractor to get a 90 degree, or as I have already taught you how to make 90 right angle, you can further make this arc. This is 60. $120, and from here another arc. This will be 90 degree. Now the perpendicular should be of length 1. Basically the length 1 will be, look here, it is going like this, and the length is 1 centimeter. 1 centimeter. Base 2, perpendicular 1, and now name it B and join OB. Join OB, which is of distance root 5. Now what you have to take an arc from here of length OB, which is root 5. From O, you have to draw this arc and it will cut number line at this point. Getting it? At this point. Name it C, and this will represent root 5. So with this question, our exercise 1.2 is also completed. Now there is a homework for all you. Draw root 6 on the number line. I can give you a hint. Look, for root 6, you basically need a base of root 5 and a perpendicular of height 1. So look, we have already know how to make root 5. This will be base, and you have to make one perpendicular of length 1 and join it with this, make an arc, and there it will be a root 6. Somewhere here it will represent root 6 on the number line. Try to draw it